The UHF connector is a World War II or earlier threaded RF connector design, from an era when UHF referred to frequencies over 30 MHz. Originally intended for use as a video connector in radar applications, the connector was later used for other RF applications. This connector was developed on basis of a shielded banana plug. Design and nomenclature. Originally the connector was designed to carry signals at frequencies up to 300 MHz, but later measurements reveal limitations above 100 MHz. The coupling shell has a 5 or 8-inch 24 TPI UNEF standard thread. The most popular cable plug and corresponding chassis mount socket carry the old signal core nomenclatures PL259 and SO239. These are also known as Navy Type 49190 and 49194 respectively. PL259, SO239, and several other related military references refer to one specific mechanical design collectively known as the UHF connector. Characteristics. Mechanical. By design, all connectors in the UHF connector family made using the 5/8-inch 24 TPI threaded shell for the shield connection and an approximately 0.156-inch diameter pin and socket for the inner conductor. Similar connectors with an incompatible 16 mm diameter, 1 mm metric thread have been produced, but these are not standard UHF connectors by definition. Surge impedance. UHF connectors have a non-constant surge impedance. For this reason, UHF connectors are generally usable through HF and the lower portion of what is now known as the VHF frequency range. Despite the name, the UHF connector is rarely used in commercial applications for today's UHF frequencies, as the non-constant surge impedance creates measurable electrical signal reflections above 100 MHz. Power. UHF connectors can handle RF peak power levels over 1 kW based on the voltage rating of 500 volts peak. The average power handling of the PTFE insulated versions is essentially set by heating of the center pin, and is therefore frequency dependent, because the RF resistance rises as the skin depth falls. Environmental tolerance. The UHF connector is not weatherproof. Applications. In many applications, UHF connectors were replaced by designs that have a more uniform surge impedance over the length of the connector, such as the N connector and the BNC connector. UHF connectors are still widely used in amateur radio, citizens band radio, and marine VHF radio applications. See also, miniature UHF connector, RF connector. References: U.S. Patent 2761110, Henry M. Diomra, Solgeless Coaxial Connector, published August 28, 1956, assigned to Intron, Incorporated. U.S. Patent 4085366, Billy Paget, Noise Reduction Device for Citizens Band Transceivers, published April 18, 1978, assigned to Billy Paget, ABCDEFGHI UHF Connector Series. Amphenol. Retrieved September 23, 2015. U.S. Patent 2335041, William A. Bruno, Right Angle Electric Connector, published November 23, 1943, assigned to Bruno Patents Incorporated, U.S. Patent 2422982, Edward Clark Quackenbush, Coaxial Cable Connector, published June 24, 1947, assigned to Edward Clark Quackenbush, Dale Polak. High-Frequency Transmission and Reception. In Henney, Keith. Radio Engineering Handbook. New York and London, McGraw-Hill Book Company. Pages 514. PL, 259 Connectors. Connectors. On Radio Me. July 2011. Retrieved May 16, 2015. Introduction to UHF. The Radio Amateurs Handbook. West Hartford, Connecticut, American Radio Relay League. 1941 pages 362 €363. In amateur work, The ultra-high frequency region is considered to include the 56 to 60 MC band and all higher frequency bands available for amateur use. ABCA offer unregistered trademark connector test results. Connectors. On Radio Me. October 2011. Retrieved January 31, 2012. TM11-5820-348-15, Antenna Equipment RC292. Department of the Army April 23, 1966. MIL HDBK 172A, Vol. I, Military Standardization Handbook, Electronic Test Equipment. Department of Defense March 11, 1964. Drawing of metric connector. RF supplier. Retrieved September 24, 2015. U.S. Patent 2,233,166, William C. Hahn, Means for Transferring High-Frequency Power, published February 25, 1941, assigned to General Electric, the UHF type connector under Network Analysis. Chris's Amateur Radio and Electronics Resource Pages. Retrieved January 31, 2012. At 432 MHz. We see a loss in the order of 1.0 dB, this equates to a transmission loss of around 6 watts with 25 watts input. Lab tests, SMA, BNC, TNC and N connectors. Connectors. On Radio Me. August 2011. Retrieved January 31, 2012. External links, UHF connector overview.